Sine, cosine, and tangent ratios. Make sure that you are in degree mode. So for the ClassWiz calculator, press Shift, Menu, 2 for angle unit, and 1 for degree. Learning intention. To use trigonometric ratios, sine, cosine, and tangent to find missing angles and sides in right angle triangles. Success criteria. I can identify the opposite, adjacent, and hypotenuse sides in a right angle triangle. I can choose the correct trigonometric ratio, sine, cos, or tan for the problem. I can use the ratios to calculate missing sides. I can use the inverse trigonometric functions to calculate missing angles. It's important to note that you can only use this, the formula that I'm going to show you, with right angle triangles. It's very, very important. It can only be used with right angle triangles, just like Pythagoras' theorem can only be used with right angle triangles. So sine, cosine, and tangent ratios. One of the most common uses of trigonometry is working out lengths and angles in right angle triangles. 3 very special ratios connecting angles and sides are given below. So sine A is equal to opposite side divided by hypotenuse. So if this is angle A, then the opposite side is always going to be opposite to the angle, and the hypotenuse is always going to be the longest side. Cos A is equal to the adjacent side divided by the hypotenuse. So cos A will be equal to the adjacent, which is the other side, so it's not the opposite and not the hypotenuse, divided by the hypotenuse, divided by the longest side. And tan A is equal to the opposite side divided by the adjacent side. So tan A is equal to the opposite side, opposite to the angle, divided by the adjacent. A useful memory aid is SOHCAHTOA. If we are given cos A equals 3/4, we can draw a sketch of a right angle triangle in which the side adjacent to A is 3 and the hypotenuse is 4. We now find the third side by using theorem of Pythagoras. So here's our right angle triangle, labeling this as angle A. Cos comes from ca, so A over h, so adjacent over hypotenuse. So the adjacent is 3, because my numerator is 3 in my fraction, and the hypotenuse is 4, because the denominator of my fraction is 4. And then the other side we'll just label as x. So we let the third side equal x, so then subbing into Pythagoras' theorem, we have c squared equals a squared plus b squared. So we have 4 squared is equal to x squared plus 3 squared, or in this case, x squared plus 3 squared is equal to 4 squared. So 3 squared is 9, 4 squared is 16, 9 comes over the equal sign, becomes minus 9, 16 minus 9 is 7, and the square root of 7 is going to be x. So in this case, x is equal to the square root of 7. So this is page 16 of the formula book, and we can see down in the section where at the bottom it says right angle triangle. So again, a reminder that SOHCAHTOA can only be used with right angle triangles. So you're not given SOHCAHTOA as such, but you can create it from what is given. So you can see that your triangle, your right angle triangle, is labeled A, B, and C. And you can relabel this as the hypotenuse for the longest side, C. The opposite is opposite the angle, A. And then the third side is the adjacent. It's adjacent to the angle. So you've got H, O, and A. And then the formula that you are given, the ratio that you are given, is sine A equals A over C. So that's where you're going to get the SOH from. So sine A equals A over C. So the A being the opposite this time, and the C being the hypotenuse. The cos A equals B over C. So that's your ca. So cos A equals adjacent over hypotenuse. And then the tan A equals A over B. So that's your TOA. So tan A equals opposite over adjacent. Example 1. If tan B equals root 5 over 2, find the value of sine B and cos B. So just make sure your calculator is in degree mode for this. So tan B equals root 5 over 2. So we're going to draw out a right angle triangle, and we're going to label one of the angles as angle B. We're going to write out SOHCAHTOA. And since the question mentions tan B, we are interested in TOA. And TOA can give us tan is equal to opposite over adjacent. So O over A, opposite over adjacent. So if we're told that tan B equals root 5 over 2 and tan equals opposite over adjacent, then the opposite must be root 5. So the side that's opposite the angle must be root 5 and the adjacent must be 2. So you can draw that into your triangle. So opposite angle B is this side here. So this is going to be root 5 and the adjacent is going to be 2. So root 5 over 2 equals O over A, opposite over adjacent. So root 5 is your opposite. It's opposite the angle, angle B, and 2 is the adjacent. So then the other side we can call x. So we're going to use Pythagoras' theorem here, which is c squared equals a squared plus b squared. We're going to label the x, which is the hypotenuse, as the c. And then the other two sides are going to be the a and the b. So then we sub into our formula, our Pythagoras' theorem formula. So c squared is going to be x squared, a squared is going to be 2 squared, and b squared will be root 5 squared. So x squared equals 2 squared plus root 5 squared. So 2 squared is 4, and root 5 squared is going to just give us 5 because the root and the squared part will just cancel. Or if you're unsure of that, just stick this into your calculator, bracket root 5 bracket to be squared, and you'll just get 5. And then 4 plus 5 is 9. So x squared is equal to 9. So x will be equal to the square root of 9. And the square root of 9 is 3. So that side there, the hypotenuse, is 3. So now we have all three sides. So now we can create sine B and cos B. So I'm going to label my triangle, and I've drawn out a separate triangle because the original triangle had labels of A, B, and C. And now I want to use the labels of hypotenuse, opposite, and adjacent. So it would just get too messy to draw it all into the one triangle. So I've just redrawn the triangle here. And we know now that the x, the longest side, is 3. So I've just drawn in the 3. So I still have root 5 is the opposite, and I still have 2 as the adjacent. So I label the hypotenuse as 3. The opposite is root 5, and the adjacent is 2. So sine B, so sine is equal to O over H, so that comes from SO. Sine is equal to opposite over hypotenuse, so O over H. So it's going to be sine is equal to root 5 over 3. So sine B is equal to root 5 over 3. So O over H, opposite over hypotenuse, root 5 over 3. And then cos B is A over H, so that comes from Ca. Cos is equal to A over H. The adjacent is 2, and the hypotenuse is 3. So it's going to be cos B equals 2 over 3. So A over H, adjacent over hypotenuse, 2 over 3. So if tan B is equal to root 5 over 2, we use Pythagoras' theorem to find the third side, which we found to be 3. And once we have all three sides, we can create any of the ratios. So sine B is equal to root 5 over 3, and cos B is equal to 2 over 3.